Hi, I'm Heidi Leonard. I'm a PhD student at the Technion Israel Institute of Technology at the Department of Biotechnology and Food Engineering, and I'm representing Team Prismatix. Here in Professor Esther Segal's lab, we are researching the interface between nanomaterials and biology. We are a highly interdisciplinary group recruiting the brightest students and fostering international collaboration. We study topics such as biosensors, drug delivery systems, and antimicrobial packaging. We use silicon microstructures to optically track bacteria on photonic chips. We have named this phenomenon PRISM after the intrinsic phase shift reflectance measurements. More specifically, PRISM allows us to track changes in refractive index caused by the presence of bacteria over time. Using PRISM, we have developed a method of rapid antibiotic susceptibility testing. This method uses a three-step approach. In the first step, bacteria are seated within the microfluidic devices containing the silicon microstructures. In the second step, the bacteria are allowed to settle to the bottom of the silicon microstructures. And in the final step, the bacteria are incubated with select antibiotics to be optically monitored.
Hey, I'm Loran Holtzman. I graduated from the Technion Department of Biotechnology, and I'm a research assistant in Professor Esther Segal's lab. I'm studying how different types of bacteria interact with our photonic sensors.
Hello, my name is Yuri Chaimov. I'm a master student in Professor Esther Segal's lab at the Technion Israel Institute of Technology. I'm working on fine-tuning bacteria sensing on our photonic chips.
So now we will show you B'nai Zion Medical Center. Come on, let's go.
Good morning. My name is Ofer Nativ, and I am the chairman of the Department of Urology in B'nai Zion Medical Center, which is affiliated to the Faculty of Medicine that is part of the Technion Institute of Technology in Haifa, Israel. We are taking care of patients with various urological problems. Among these are the infections. And as you may know, urinary tract infection in particular, are the cause of a lot of morbidity, mortality, and has an economic burden. One of the main limitations of the current treatment is the relatively long duration of time that takes between the admission of the patient to the hospital and receiving the susceptibility of the pathogen to a specific drug. Therefore, when we heard about the possibility of getting a fast test for identifying the susceptibility, the antibiotic that is suitable for the specific pathogen, we're very happy to collaborate with the group of researchers from the Technion.
Hi, my name is Sarel Lachmi. I'm a professor at the Department of Urology. I'm the vice chairman of the Department of Urology here at the B'nai Zion Medical Center. We're happy to collaborate with Dr. Segal Lab and Dr. Leonard at the Technion, looking for a quick test for antibiotic susceptibility. This is our department of urology, a very busy department. We have 26 beds and 100% occupation here. We're dealing a lot with urinary tract infections, nephrostomy, resistant bacteria, and it is essential for us to get a quick test for antibiotic susceptibility for the sake of the patient and for our ability to avoid resistant bacteria. We got a Helsinki approval for this study, and we got an informed consent from every patient. Every patient that is admitted for the department is, after an extensive explanation and agreement to participate in the study, we take a clean urine sample and we simply divide it to two. One sample goes to the regular laboratory to get susceptibility and result, and and one sample goes to Dr. Leonard to have the special test in the same urine samples. And afterwards, we compare the samples. Of course, that Dr. Leonard is blinded from the results that we got from the laboratory, and only thereafter we compare the results. This is the Bnai Zion Medical Center located in Haifa in the Midtown. It's quite a busy hospital. It is academic, it is affiliated with the Faculty of Medicine, Technion Israeli Institute of Technology, provides all the medical assistance that the patient can get.
I'm here in our pathogen lab, and I am working with one of our microfluidic devices. You can see that in one device we have 10 channels, and each channel has a photonic chip. This photonic chip is our sensor. And I will now show you how we analyze our urine samples in these photonic devices. I have a fresh urine sample that we collected from Bnei Zion this morning. In each channel, I will pipette 40 microliters of the urine sample that I have. After letting the sample sit for a couple minutes, we then add antibiotic solutions into the channels, 40 microliters again. So I have now taken the device with antibiotics loaded into it and the urine sample, and I'm placing it underneath our optic setup. So right now we have our photonic chips being illuminated by white light, and the signal is being processed by a spectrometer in the back, and we can read the signal on our computer. This is what a typical optical signal looks like. And furthermore, the microfluidic device is on a moving stage. So we can actually record what happens in all 10 channels, and every 30 seconds, the stage moves to another photonic chip.
Hello, my name is Esther Segal, and I'm an Associate Professor of Biotechnology and Food Engineering at the Technion Israel Institute of Technology. Over the past several years, we've been working towards the development of a rapid phenotypic antimicrobial susceptibility testing. Our project was funded by the Meriah Institute and is now being funded by the Israeli Ministry of Science, who supports the collaboration between our lab and the Department of Urology at the Bnei Zion Medical Center. As I demonstrated, our technique integrates the silicon photonic chips with easy-to-handle microfluidic channels, and in the future we would like the entire system to be completely automated. We have applied for the Discovery Award in order to be able to buy additional microfluidic devices and to carry out studies on other pathogens and screen as many clinical samples as possible.
Hi, I'm Lee Canahan, Professor of Nanomaterials for Biomedicine and Photonics at the University of Birmingham in the UK. My research over the last 30 years in both UK industry and academia has focused on both microstructuring and nanostructuring silicon to extend the functionality of silicon chip-based technologies. I'm really looking forward to collaborating with Team Prismatix on what is a very exciting venture.
Thank you for considering us for a Discovery Award and watching this video. If you have any questions, feel free to contact Heidi at the following email addresses. We look forward to hearing from you soon.